All right, so let's make ourselves a list of characteristics of covalent compounds. We have one for ionic. We'll make one for covalent. Most of them
Mr. Vanover to the high school office, please. Mr. Vanover to the high school office.
are gaseous or liquid. However, many are solids. All the ones you worked with yesterday were solids. So remember that we already said the majority of compounds are covalent compounds, whether that be polar or nonpolar. There's way more covalent compounds in the world than there are ionic. Even though the ionic ones, in what they do and how they react, most of the time are a little bit cooler to observe than the covalent ones. There are way more covalent. What would you tell me about their melting points and boiling points based on what you saw yesterday? Did you see a difference in boiling points? Or, sorry, I should say melting points. We didn't boil them. See a difference in melting points? Did some melt and others not melt? Yeah, that's a good distinguishing characteristic between the two. What messes you up sometimes are those darn polar covalent ones, because they might not dissolve, but they might melt at a low temperature. So they kind of are a little tricky in that they might exhibit characteristics of both, depending upon how polar they are. Most covalent compounds have low melting and low boiling points. Let me ask you this question, and I have your papers out so you can have them back for when you do your conclusion. Did you find those that had low melting points to be conductors or non-conductors? Do you remember? Don't remember? Okay. Hopefully, when you look at your data, when you get those papers back, you will see that those things that had low melting points were generally non-conductors. The majority, not necessarily what we work with in here, because majority includes everything, and we have very specific things that we work with, but the majority of them are non-polar in nature. But don't forget, there are lots of polar ones as well. I would say that, did you find some dissolved and some didn't? Okay. Did you find one that clearly dissolved in alcohol and one that only like maybe partially dissolved? You may not have picked up on the second one, I'm not sure. Do you remember, did you have one dissolve in alcohol? Do you remember what number it was, anybody? I should have gave you your papers back. Number one? I would expect it to be one. Usually they are soluble in nonpolar solvents. And remember the ones we've looked at in lab. We've looked at mineral oil, we've looked at alcohol. There's an organic compound that pops up over and over and over, benzene, and the benzene ring, that would be another one that dissolves covalent stuff well. The other interesting thing about these covalent compounds, and I want you to think about this and see if you could explain why. have a slow reaction rate, much slower than ionic compounds. What do ionic compounds have when I want a reaction that covalent compounds don't? If I try to separate them, what am I going to get in an ionic compound versus a covalent compound? What do I get when I separate an ionic compound? I get a metal and a nonmetal with what? Both of them have a charge. Yeah, so they have a charge. So they are, when I separate a covalent compound, I don't get anything with a charge, so it's less reactive. There's less bond energy there. All right. So now you should have nice distinguishing characteristics for both covalent and ionic. The last thing I want to do is walk through, like, step by step, give you a step-by-step procedure, because I don't know, and I don't even know, I can't remember, I gave your papers back. I don't know if anybody got all of those molecular compounds correct when you did your Lewis structures. So let's just walk through so you've got it in your notes. Lewis structure procedure. The first thing you want to do every time is to find the number of electrons from each atom. So I'm going to go through, if I had like SO2, I would go, okay, this is 6, this is 6, and my second one is 6. So I totally have 18 electrons to work with. So separate them, think of them as individuals, but think of your electrons as a total that you have to work with. So I'm going to say find total. Find the total number of electrons you have to work with. Then you are going to place the atom with the most points of attachment in the center. And then you begin to place electrons. Once you think you have all your electrons placed, you need to count the total of electrons and check for octets. This is where I saw the biggest problem. We had some elements that had way more than an octet. We had some that had less, and we had some whole structures that had more electrons than they should or less electrons than they should. So that's the thing that you always want to check. And then I would say if your octet is not met, then try double or triple bonds. Don't just go in and put in some triple bonds or some double bonds. You need to like draw it and then move them so that you have the correct number. Okay. Number 7, something to remember. Lone electrons should be in pairs. When you've got all that done, and everybody's got all their octet, if there are electrons left over, place them around the central atom. I'm going to show you what that looks like. Some electrons can have more than an octet and be happy. There aren't that many. Sulfur is one of them. I'm trying to think of any that you might see. The only other one we're going to worry about is phosphorus. Sometimes the weirdos down in the D block will take more than 8 too, but we're just going to focus on these 2. So let's look at, flip the page here. This is a molecular compound, SF6. Ooh, how would I name that with my prefix? Sulfur what? Anybody want to tell me? Loud? Yay! Hexafluoride. Two nonmetals, covalent compound. So, let's look at this. Plus 1, 2, 3, 4, 5, plus 6 fluorines. Now I want you to go to your periodic table. I want you to see how many electrons does sulfur have, and well, we should know fluorine. How many electrons does sulfur have? Okay, add them up and see what you get. How many total electrons do I have to work with? What you got, Jacob? How many? He got 48. I got 48. Did you guys get 48? All right, so I've got 48 electrons to work with. Now, pay attention to how I word this. Like, do I ask you to write the equation, then give the total Lewis structure? Or do I just ask for the Lewis structure? If I just ask for the Lewis structure, I don't need you to go 1, 2, 3, 4, 5, 6, and then put, you know, all 7 on here. If I ask for the equation in the Lewis structure, then you should do that. So let's start by, my lone man out is sulfur, and he or she, it, I should say, also has the fewest number of electrons, right? So I'm going to put sulfur in the center, but I'm not going to put any electrons on it yet. I'm going to think, okay, it's sulfur. I know it's weird. I have to attach all of these guys to sulfur. So let's start by doing that with just a single bond. When you have a situation like this where you have one and then many, the one will usually go in the center and other things will attach off of it. So let's look and see how many of electrons have we used. 2, 4, 6, 8, 10, 12. Okay, so I've used 12, so that leaves me with 36. But let's go ahead and fill in our fluorines and see what happens. Total up your electrons and see what you get. Are there any extras? No, there shouldn't be, so we don't have to worry about it. But always count and see if there are extras. I'm going to give you one later where there are. If there were extras, I would just come in and put them somewhere on sulfur like that. Usually we put them at the top first, but it doesn't really matter. In this particular case, sulfur has more than an octet, yes? Yeah. Do all my fluorines have an octet though? Yeah, and they have to obey the rule. They're not an example that doesn't obey the rule. All right, so let's try a couple. Yeah.
Can sulfur ever have less than 8?
Less than 8? No.
So
No.
can we go over, we did like SO3 on
Mhm.
that.
I have that written down to go over actually, so we'll do that right now. All right, so let's look at SO3. That's actually one of the ones I wrote down to look at. All right, figure out the total number of electrons you have to work with. And then just stop. Okay, Jonah, what's the total number? What's the total number of electrons I have to work with? Did you figure that out yet? 24. So I've got 24 electrons to work with. Now here's my next question. When I look at this, they all have 6 electrons, right? So one isn't any better than the other to put in the center, but what should I pick to put in the center? The one that's all by itself. So I'm going to pick sulfur. And then I'm going to single bond in my oxygens. And then I'm going to go ahead and make, the next thing I would do would be to go ahead and make an octet around each of my oxygens. And then I'm going to stop and I'm going to check for octets and I'm going to check for the number of electrons. So 8, 16, 24. Everybody see how I did that? I just looked at my total number of electrons. So I've used the right amount, but now, and this is what some of you didn't do, I think, on the little practice thing. If I look here, check, I've got an octet. If I look here, I've got an octet. If I look here, I've got an octet. But if I look at my sulfur, sulfur sad. No octet. Now, I can't just put 2 more electrons in there because I don't have them. What I can do though, remember we're sharing, I can take an octet or take a pair from any of these octets and make it a shared bond. So what I would do, I'm just going to pick this guy on the bottom. It's irrelevant which one you pick. I'm going to take these and I'm going to get rid of them and I'm going to move them up here and I'm going to share them with sulfur. I haven't added any more electrons. Oxygen still has an octet and now sulfur has an octet. So sulfur's happy too. Everybody's happy. It's a win-win. Always do it that way, and if you need to move electrons, you can. We can have an ionic compound that is made up of 2 polyatomic ions or a monatomic ion and a polyatomic ion. Within polyatomic ions, interestingly enough, even though they have a charge, we normally see covalent bonds within a polyatomic ion. That polyatomic ion goes on to make an ionic compound with covalent bonds within it. That's when we see polar covalent sometimes or very weak ionic. So let's look at this. Let's look at how we draw a polyatomic ion or a compound with a charge. That was the little challenge I put down at the bottom. I think some of you got it, some of you, I don't know, didn't. So let's look at this one. ClO2, 1 minus. Find your total number of electrons. Don't do anything until you find them. And don't forget to add on your extra electron that negative sign gives you. So I have 7 in chlorine, 6 in my first oxygen, 6 in my second, plus my 1 extra guy. So what is that, 20? Is that right? Did you get 20? Okay. So when I look at this, I have 2 oxygen and 1 chlorine. Chlorine's alone. So in this case, I'm going to put chlorine in the center. And then I've got 2 oxygen, so I'm just going to bond them on there. Then I'm going to go ahead and take these outside guys and work with them first. I'm going to give them both an octet. And then because this is an ion, I'm going to stop and check myself. See, I want to know how many electrons I have. So let's see, I've got 8 and 8. I've used 16, right? So I've got 4 left. So I'm going to go 18, 20. Now I've used 20 electrons. Now I'm going to check for octets. Sweet, there we go. Looks to me like everybody has 8. Now the correct way to write this, because it is an ionic polyatomic ion, is like this. Cl, and I'm going to separate this out just because it'll be easier to see since I drew the circles. Just like we did in the ionic equation, when something had a charge or a transfer, we bracket it. I want to try one more. I don't remember if I put this one on your little practice paper from the other day or not. Yeah, was that the one? Okay. So this will give you, if you didn't get them, this will give you the answer for both of them from that practice sheet. You want to try this one by yourself? Yeah, let's try it alone and then we can talk through it. Did you get one of those too? Yeah? Awesome. Now, do you see what I did here? Some of you have it this way? Did some of you have it this way? Okay. These things are called resonance structures. And basically that just means that there are 2 ways it can be written and be correct, or maybe 3 ways. And truly, like in the real world, we don't know which way something is bonded. We know it can be any of these possibilities. There are some calculations we can do to find out which one's most probable or how it spends most of its time. In fact, there's a section in your book if you'd like to read about that. You can. It's not something that we cover, but just know that there sometimes is more than one possible way to do this. And when there is, it's called a resonance structure. And I'm going to give you one resonance structure that I want you to try. See if you can come up with more than one possible Lewis structure for this covalent molecule. Stand up when you've got them. Or you think you've got them. Okay. Turn to somebody close to you or by your lab station and see if you guys agree. Oh, that's Do yours look like mine? Except I made a little tiny bond there because I put my O's too close together. No? What'd you do? Oh, I bet you have too many electrons. Or not enough, one or the other. Gotta count your total. Okay, so listen, some of you may have tried to make a triangle. Did it work out with electrons? Yeah, The next thing we do here in a little while is something called Vesper theory, which is about molecular angle geometry. So there's a reason it's not in a triangle. We're not going to go into that right now. If I saw that and it counted up with electrons, I would probably take it at this point. Once we learn that bonding theory, you'll know that it's wrong because of what's there and how many electrons you have. So what I'm going to have you do now, I have some practice ones out. I have your labs from yesterday out. I have your thing about your lab conclusion out, and I also have the correct compounds with bond type like covalent, ionic, the ones that you picked, so that you can check and see if you were right. I don't care which one of those you work on, but you need to be working, and you need to be working alone. If you want to try the Lewis structures first while it's fresh in your brain to get it in there even a little better, do that first. I don't care. They're all laid out. I need to take a minute and put these first couple pages up for Lydia. So Lydia, I'm not going to talk about these, but they're for you for in your notes. I forgot to turn the recorder on. I hope you're not sick. I think she might have went on a college visit. That isn't going to work. Okay, so you guys can get your stuff and get your Chromebooks. Yeah.
What are the conclusions?
Conclusions will be due, what's today, Wednesday? I'm going to make them due Monday. You're going to have tomorrow as a work day, but that way you don't have to study for a quiz and work on a lab report all at once. Yeah, I do need your problems turned in, you guys. Okay, Lydia, if you have questions on this first stuff, just come see me when you get here tomorrow. Yes.